Good morning. Today is March 15, 2020, and this is Teacher Ariel. Our subject is measurement and experiments. And our topic for today is using an analog multimeter as DC ammeter, or a device used to measure DC current. Let us now start. What are the things or important things to consider in using an analog multimeter as a DC ammeter? 1. Safety precautions. 2. Ranges. 3. Range selector switch. 4. Zero corrector, pointer, scales, and polarity. If you're going to remember our video last week, I had explained all these things to you. So I think no need for me to repeat this subject matter. So we will proceed on the DC ammeter. This is an example of an analog multimeter wherein we are going to use this as a DC ammeter, or a device used to measure current. So if you are going to look at this is your range plate. The DC ammeter ranges are located here. So we have 0.3, 30 milliampere, 3 milliampere, and we have 60 microampere. Again, the ranges are 0.3 ampere or 300 milliampere, 30 milliampere, 3 milliampere, and 60 milliampere. As you can see, we have here an indicator that is abbreviated as DCA. Okay? This is DC current or DC ampere. So we will focus on our study in this part of the multimeter as a DC milli ampere or as a DC ammeter. Okay? Now, as I've said, in DC, we need also to follow certain polarity. And it was explained also last week. Now, let's focus on the scales. For us to be used, let us focus on the scale for us to use in using this analog multimeter as a DC milli ammeter. So we will be focusing our scale for 300 because we have 0.3, 30, and 3, and we will focus on 60 because we have here 60 microampere. Now, try to take a look on this paper, which has the DCV or DCA scale. So again, we have 300, we have 60, and this 360 scales, this is the scale that we are going to use for our DCA measurement or direct current ampere measurement. Now, let us start for 60 micro. For 60 micro, we will use the scale of 60, wherein every division and subdivision is counted as 1. Like for example, this line, this is 1. Why? Again, let's try to compute on how to count the scale. So let us say we have the highest main division, which is 10 here, minus 0 is equal to 10 divided by the number of lines in between 0 and 10. So there are 10 lines. So 10 divided by 10 is equal to 1. So if we're going to use the scale of 60, we will count this subdivision as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? And so on and so forth, until we reach the maximum of 60. So each line or each division or subdivision is counted as 1. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and so on and so forth, until we reach 60. Okay? So if you're going to read this as is, meaning the scale reading is the same as the current rating, only that the unit is microampere, like this, for example. So we have the range of 60 microampere. The counting is by 1, and the reading is the same as the scale reading. Okay? Next, we have the 3 milliampere. The 3 milliampere, okay, we will use the scale of 300. From 0 to 300. And the counting of every line or subdivision is by 5. Let us try again the equation. So the highest division is 50, which is 50 minus 0 is equal to 50 divided by the number of lines or subdivision inside 0 and 50. Okay, we have 10 lines over here. So 50 divided by 10 is equal to 5. So if you're going to use this scale of 300, 0 to 300, each line is equivalent to 5. Like for example, this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, and so on and so forth until you reach 300. Then the scale reading will be divided by 100. Okay, again, the scale reading will be divided by 100, or you just need to move 2 decimal places going to the left. Again, the scale reading will be divided by 100, or you just move 2 decimal points going to the left. In later discussion, I will show to you on how to convert these things for you to understand. Now, let us proceed to 30 milliampere. In the same manner, we are going to use the scale of 0 and 300. I mean 0 to 300. And the counting is by 5. 5, 10, 15, 20, and so on and so forth, until you reach the maximum of 300. The scale reading will be divided by 10. Again, the scale reading will be divided by 10, or you just need to move 1 decimal point going to the left. I'll repeat. For the range of 30 milliampere, each line is by 5 and divided by 10, or just move 1 decimal place going to the left. Also, I will explain some example, or I will show you some example on how to use this 30 milliampere. Then next we have 0.3 ampere or 300 milliampere. The scale that you are going to use is 0 to 300. The divisions and subdivisions is equivalent to 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, until you reach 300. Okay? There are two things you need to consider. If you are going to read it as a milliampere, 300 milliampere, then you need to read it as is, or the same. The pointer or the scale reading is the same as the actual reading if you are going to use it as 300 milliampere. But if you are going to use a 0.3 ampere, you just need to move 3 decimal places going to the left, or divided by 1,000. Again, if you are going to use this as milliampere or 300 milliampere, the scale reading will be the same as the final current reading. Again, if you are going to use this as 300 milliampere, the scale reading will be the same as the current or actual reading. But if you are going to use 0.3 ampere, you just need to move 3 decimal places going to the left, or divided by 1,000. Okay, take a look at this scale. So, we have an example of letter A, wherein we will focus our study in this letter A. First, we use the scale of, the range of 60 micro. 60 micro. Okay? So our first activity is we will be using 60 micro ampere. So 60 micro, one line is equivalent to 1. And the scale reading is the same as the final reading. Again, so 60, 1, 2, 3, 4, 5, 6. So we have scale reading of 6. Then the actual reading is 6 microampere. 6 microampere. So simple, right? Again, for 60 microampere, we will just count every line as 1, like 1, 2, 3, 4, 5, 6. The scale reading is 6. The final reading is 6 microampere. That's it. The next, we will proceed on range 3. Range 3. So here, we have range 3 milliampere. To range 3 milliampere, we are going to use the scale of 300. 0 and 300. And each line has equivalent of 5. So this is 5, 10, 15, 20, 25, 30. So this pointer points to 30. Okay? The scale reading is 30. So 30 divided by 100, we have a reading of 0.3 milliampere. Again, for the range of 3, we will be using 0 and 300 scale. 0 to 300 scale. And each line is equivalent to 5. So 5, 10, 15, 20, 25, 30. Our scale reading is 30 divided by 100 will be 0.3 milliampere. Or you need to move 2 decimal places going to the left. Like 1, 2. So we have 0.30 milliampere. Okay? Or 0.3 milliampere. That's it, the final reading. Then, next, 30 milliampere. For 30 milliampere, the same scale we're going to use from 0 to 300. And each line is equivalent to 5. So this is 5, 10, 15, 20, 25, 30. So our scale reading is 30. Divided by 10, we have 3 milliampere. Or you just move 1 decimal point going to the left. So we have 3 milliampere. Again, for the range of 30. For the range of 30, we will use the scale of 0 to 300. And the equivalent or the value of each line is 5. 5, 10, 15, 20, 25, 30. So we have 30 here as your scale reading. And the final reading will be 30 divided by 10 is equivalent to 3 milliampere. So we have 3 milliampere. This is for 30 milliampere. Now let us proceed to the range of 0.3 or 300 milliampere. So I have here 0.3 ampere or 300 milliampere. Again, the range, the scale that we are going to use is 0 through to 300. And the value of each line is by 5. So we have 5, 10, 15, 20, 25, 30. So we have here 30 as the scale reading. So, if we are going to use this 300 milliampere, again, the same, or times 1, so we have 30 milliampere. Okay? But if we are going to use it as an ampere, like 0.3 milliampere, so 30 divided by 1,000. What do you think it will be? So 30 divided by 1,000. So you just need to move 3 decimal places going to the left. 1, 2, 3. So our reading is 0.030 ampere or 0.03 ampere. 0.03 ampere is the same or equivalent as 30 milliampere. Okay? Is it clear? Now, let's proceed to activity or exercise letter B. So, we have here blank and we try to read the scale reading here for letter B. Okay? For 60 by 1, so we have 20, 21, 22, 23, 24, 25. So we have 25, the scale reading, and our current value, actual current value is 25 microampere. Okay? Then let us proceed to range 3. Range 3 is by 5. So we have here 100, 105, 110, 115, 120, 125. So this is 125 as our scale reading. Our current value will be 125 divided by 100. So we have 1.25 milliampere. Why? 125 divided by 100 is equivalent to 1.25 milliampere. Or you just need to go to the left 2 decimal places, 1, 2. So this is 1.25 milliampere. Next is range 300 milliampere. I mean 30 milliampere, sorry. 30 milliampere. The scale to read is 0 to 300. And then again, the value of its line is by 5. So we have here 100, 5, 10, 15, 20, 25. So we have also 125. Our scale reading. Divided by 10, we have the current value or actual value of 12.5 milliampere. Okay? Now, let's proceed to 300 milliampere or 0.3 ampere. Let us first count it as 300 milliampere. Our range is 300 milliampere. So again, we will use the scale of 0 and 300. Each line is by 5. So we have here also 125. So our final reading, current value is 125 milliampere or 125 divided by 1000, we have 0.125 ampere. Okay? So again, we have here 125, our scale reading. Then 300 milliampere, we have 125 milliampere. For 0.3 ampere, we have 1.125 ampere. So at home, please try to answer problem letter C, 60 micro, 3 milliampere, 30 milliampere, and 0.3 ampere, and also problem letter D, 60 microampere, 3 milliampere, 30 milliampere, and 0.3 ampere. So please answer letter C and D at home. So again, let me demonstrate to you a practical application of using an analog multimeter as a DC Milli Ampere or DC ammeter. What are the things that we need to use in our practical application of this multimeter? So we have power supply, or any DC source. We have breadboard, we have load or a resistor, then we have connecting wires, and analog multimeter as DC ammeter. Okay, so let us proceed. So we will put this resistor or the load into the breadboard. Then we will connect the connecting wires, or positive going to the resistor, then the negative going to the resistor. Then let us connect a wire going to the source or power supply. So positive to positive. Then let us connect the negative wire or the wires going to the negative portion of the power supply. Now, we have a complete circuit wherein we have one resistor connected to a power source or DC source. Let's try to, like for example, we put 5 volts as supply. Okay, we put 5 volts as supply to the resistor. Then, how are we going to connect an ammeter to the circuit in order for us to measure the current of the resistor? Okay? So, in any manner, if you want to connect an ammeter to the circuit to measure current, you can cut like the positive terminal and put the positive test prods or test probe to the positive, and you connect the negative test probe to the resistor. Okay, again, if this is a complete circuit, you need to cut the circuit by removing the power supply or the positive supply of the battery or power source, then connect this positive supply to the positive test probe like this, then connect the negative to the resistor where before the positive terminal was connected. Or in any manner, you can cut also the negative terminal of the battery and connect it to the negative test probe of the multimeter and connect the positive test probe to the resistor where before the positive terminal of the battery was connected. Okay? So as you can see in my demonstration, it is like this. Now, let us try to measure the current. So your multimeter is off. Then let's say we will use 0.3 ampere or 300 milliampere. Let us connect. Remove the positive terminal. Connect to the positive test probe. And connect the negative test probe to the resistor where the positive terminal was connected. Okay? Then, now, we have a reading of 50 because we will be using 0 to 300 because our range is 0.3. So, this reading is 50 milliampere or 0.05 ampere. Again, this is 50 milliampere or 0.05 ampere. So, the final reading is 50 milliampere or 0.050 or 0.05 ampere. That is on how you're going to use this analog multimeter to measure current, or using this analog multimeter as a DC ammeter. Next week, topic is Ohm's law, using analog multimeter to represent the basic theory of Ohm's law. Thank you very much and have a good day.